Okay, we're going to look at properties of logarithms today. Probably this is a review. Okay, so log base what of x? This is log base 10 of x. Remember, 10 is an integer number. Ln of x, this is the ln of x, is equal to the log base e of x. So just a reminder, those are from last week. So first we're going to use change of base. So if this is used like when you couldn't put a base value into your calculator a long time ago, and that's not a reality anymore. But sometimes we need this to simplify an equation. If I have the log base a of x and I want to use, say, log base 10 or log base e instead of some other number, like this 4, then I can split this up as log base 10 of 25 over log base 10 of 4, okay? Or you can choose any base, so you can actually do the ln of 25 over the ln of 4 if you want. Put those both in your calculator and make sure they're equivalent, okay? We can condense this using change of base. If I have two different logarithms being divided, I can change this to being the log of the top number was my x value, the bottom number was my old base value. So we have 2 of 16, and then I could actually evaluate that. That is the log 2 to the what is equal to 16 will be 4. Okay, product property. So if I have two numbers being multiplied together inside, so as the input to the logarithm, I can separate them into two separate logarithms being added together. So I'm going to rewrite this. The ln of 2 times 3 would be the ln of 2 plus a second ln of 3. Okay, this is expanding. And then we're going to condense. Okay, so same bases, so we can condense this into one input. So log base 3 of 7 times 10, this is log base 3 of 70. Okay, quotient property. This is really similar to the product property, but when the input is being divided, we are going to subtract these two logarithms together. Think like when you divide numbers with exponents, like x squared over x to the first. What do you do with the exponents? You subtract them. That's what we're doing here. Okay, so we're going to expand. This is log base 10 of 2 minus log base 10 of 27. Okay. The next one, we're going to condense. I have two logarithms, each having the same base. Then I can combine the inputs. So the ln of 100 over 5, which is the ln of 20. Okay, last property is the power property, excuse me. You probably have seen this one before. So I don't like the way this one's written. We're going to rewrite it. The log base a of x to the v power. So when your input is being raised to a power, we can take the power and put it in front. So this would be 3 log base 4 of y. Okay. The next one, 3 ln of x. If I'm multiplying the ln of x, I can move this back to raise the input to a power. So the ln of x to the third. Okay, you may be asking yourself, wow, how this magic works on this last example. So let's just do a little y. Okay, if I have the log base 4 of, we're going to expand this, y times y times y. Using the product property, I know that this equals the log base 4 of y plus log base 4 of y plus log base 4 of y. How many log base 4s of y's do you have? Oh, I have 3 of them. 3 log base 4 of y. There you go. Okay, so I want you guys to expand these next 5 logarithms. I'm going to post the answers for you on your agenda. And then go ahead and expand or condense these 6 logarithms, and I will post the answers for you on the agenda. There are lots of ways to do these correctly. So if you ended up with the same thing as me, you probably did it correctly. Please check with your neighbors.